Okay, so uh, I said in the first class of queuing theory that whenever a person or a customer joins in the line, yeah, then record it. Then record it, please. It will be very helpful. Thank you. Okay, so whenever a customer tries to be engaged in a line or in a service center, what he is interested in, the first thing he will take interest how much long the line is. That means what is the total length of the people in the system. So system means people in queue plus people getting serviced. So the number of total person involved or engaged in the service center, total number of queue waiting in queue, total number of people waiting in queue plus total number of people taking service together is the number of people engaged in the system. That is called ls, l suffix s. It represents a number of customer. Lq is the people number of people who are waiting in queue, waiting in line. This is LQ. So LS is equal to number of people waiting in line plus number of people getting serviced. So then LQ is number of people in line. That will be equal to number of people in the system minus number of people getting serviced. So this is LQ. And what will be the customer will take interest in? He gets the number of people. That is okay. The number of people in line plus the number of people in system. Okay. Now then, what else he will be interested in? He will be interested in the number of the amount of time he will be engaged in the system. That means the number of the quantity of time he will he will be engaged in line, that is WQ. The quantity of time he will be in queue, that is WQ, plus the quantity or amount of time he will be serviced, he will get the service, that is the servicing time. So total number of people, that is in the system, is LS. Total number of people in queue is LQ. The total amount of time he will be engaged in the system is WS, and the number of quantity of time he will be engaged in queue, that will be WQ. Okay. Now this LS and WS is connected like LS equal to lambda into WS, where lambda is equal to the input rate, the customer arrival rate. Okay. And LQ is equal to lambda into WQ. That is the internal relationships between LQ and WQ. So these two relationships, the internal relationships between LS and WS and LQ and WQ. So these relationships which connecting the internal connections, these are called Little's equation. So let us discuss it with a problem. Let us discuss it with a small easy problem. Okay. So, sorry. Okay. Now, let us have some arbitrary data. The arbitrary data means the input rate which is lambda, say 8 number of people per hour. Okay. Service rate mu, say 9 per hour. Then rho will be equal to 8 by 9. Rho means rho means the traffic intensity, which is lambda by mu. Now, our job is to find out the possibility that there is no queue. Okay, I'll write out the questions for you. Find the possibility that there is no queue. Option B, question number B. Find the probability that there is 10 people in the system. The probability that there is 2 or more people in the system. Also find out the total number of people in the system, total number of people in line, in queue, the expected time to be spent in uh, in the system, total quantity of time to be expended in the system, and the quantity of time will be spent, expected to be spent in the queue. Okay, so this is what we have to find out. Now to find them out, we these formulas will be enough what we have discussed here. So let us solve this small very easy problem, and then later on we will try to find out other difficult problems also. So now here we said that find the probability that there is no person in the system first, which will be P naught. P naught means there is 0% in the system or no person in the system. Okay, so that is, we have discussed in the earlier class that P naught is equal to 1 minus rho, which will be 1 minus 8 by 9, that will be 1 by 9, and that will be 0.111. So if no one in the system, then the server is free or idle. That means the servicing is not going on, the server is idle. Means the service counter is not operating because there is no one in the system. The probability that there is no one in the system is 0.111 or 11.1%. Now the probability that the server will be busy, so the probability that the server will be busy will be equal to, this is the probability that it will be, there will be no one in the system. So this time server will be idle. So the rest of the time the server will be busy. So which will be 1 minus P naught, and that will be equal to 0.888. Now the problem said find the possibility that there is no queue. So probability that there is no queue, how can we achieve that? We can get the probability of no one in the system plus probability that no one in queue plus probability that one person is getting serviced. One person is getting serviced. Now think why we are writing this line, because probability that there is no queue means what are the options we have? Probability that no one in the system, then there will be no queue. Again, I mean, these will be together. No one in queue, probability that no one in queue, only one person is present in the system and he is getting serviced. So that means there is one person in the system and no one in queue. And we are discussing about the single channel, the mode 1. Okay, there are 4 modes, there are 4 models. This is model 1, where we use a single service counter. So that's why to get the probability of no queue, these are the options possible. Either there is no one in the system, or there is one person in the system and he is getting serviced and no one standing behind him. So actually, this is basically probability of P naught plus probability of P1. Now if you join them, what will get? P naught plus rho into P naught. So here we can take out P naught outside, put the values, and inside it is 1 plus rho. Okay, upon simplification, we get 0.2098. So probability that there is no queue is 0.2098 or 20.98%. Okay, is the problem clear to you? This is how you have to think. What is the, if you have to find out any probability, then you have to think how we can achieve this probability. So here we can achieve in 2 ways. That's why I've written 2 probabilities separately. Now
লেখাটা কিউটা নো কিউ পি যেটা আছে
কোনটা বলো? এটা
হ্যাঁ এটা
probability there is no queue, no queue, no line.
Yes sir.
Here there is no one in the system, here no one in queue plus one person getting service.
Yes sir.
Okay, so now next question, find the probability that there is 10 people in the system. So probability that there is 10 people in the system, or P10, and that will be equal to, we have found out in the last class, root to the power n into P naught. So rho to the power 10 into P naught and is equal to 0.888 to the power 10 into 0.111. On simplification, it will be 0.0341. So the probability that there is 10 people in the system is 3.41% or 0.0341. So next question says, find the probability that there is 10% in the system. Oh, that is what we have found out. Next question. Probability that there is 2 or more people in the system. Probability that
Sir?
there is 2 or more. হ্যাঁ বলো।
স্যার রোর ভ্যালু তো স্যার 8/9।
8/9।
তাহলে স্যার আপনি রোর ভ্যালু স্যার 0.88 যেটা লিখছেন ওটা স্যার প্রবাবিলিটি দ্যাট দ্য সার্ভার উইল বি বিজি।
আচ্ছা দাঁড়াও 1 মিনিট। রোর
স্যার
ভ্যালুটা
তো
আমি
0.111 হবে।
এটা রোর ভ্যালু তাই তো 8/9।
হ্যাঁ স্যার
হ্যাঁ সরি
8/9।
সরি। আর রোর ভ্যালু 8/9 হলে তো 0.888 হবে তো। সমস্যাটা কি?
না স্যার
রো ইজ
8/9।
8/9। 8/9 করো। 8/9 করলে তো 0.888 হয় তো।
হ্যাঁ স্যার ঠিক আছে।
ইয়েস স্যার ঠিক আছে।
Okay, sorry. Okay, so next question. Next question is probability that there is 2 or more person in the system. So if you can remember that we have said earlier, probability that there is one number of person in the system P1 plus probability that there is 2 person system in the probability that there is 2 person in the system, that is P2. Similarly, there is 3 person in the system is P3, and similarly the infinity number of person in the system, which is basically 1. Okay, so there is more than 2 number of people in the system, that is basically 1 minus P3 plus P4. Oh sorry, I mean more than 2. Okay, so P1 P2 will be cancelled out. P3 plus P4 plus dot up to infinity, that is the probability we need to find out, because these are the terms which tells us that the total number of people in the system is more than 2. So we get this as 1 minus P1 minus P2. This
হ্যালো
is the
স্যার,
term.
এখানে
বলো।
বলেছে দুজনকেও না, দুজন অথবা দুজনের বেশি, তাহলে দুইটাকেও তো নিতে হবে।
না দুজন 2 or more. 2 or more. Okay, yes, right. 2 or more, not more than 2. Sorry, I got the question wrong. This is written as probability that there is 2 or more person in the system. So of course, right, you are very good. Very good. So we have to take P2 here. I have read the question wrong. So P2 to be taken here. So this will be 1 minus P2. Okay, so 1 minus P2, sorry, 1 minus P1. I'm very sorry, 1 minus P1. So P1, the value of P1 is equal to rho into
P0 P1।
yeah,
So rho into P naught.
rho into P naught. So upon putting the value, rho is 0.888 into P naught 0.111. Okay, so upon calculation, just let me calculate it into 0.111, sorry, 0.111. Okay. 1 minus, sorry, 1 minus 0.888 into 0.111. Okay. So we get, please calculate and tell me the answer. I'm having a problem.
Sir, 0.904114.
0.9014. 1432. Okay, got it. I am getting old, you know. I'm having difficulty with my phone. Every time I sit with my calculator. Okay, got it. Calculator is much easier to operate. Okay, so 0.901432. Fine. So that is the probability that there is 2 or more people in the system. We have forgot one more thing here. We have forgot that there is also a possibility that there is no one in the system here. That is also a possibility that there is no one in the system.
Yes, sir.
Right?
Yes, sir.
So I have forgotten that. That is my mistake. So here, this portion is okay. 2 or more person in system. That probability given by this. So this P naught will be again transferred here. So it will be like this, and it will be minus P naught will be 0.111. So minus 0. P naught is 0.111. So we need to again minus it 0.901432 minus 0.111. Okay, so 0.790432. So this will be the answer, that there is 2 or more number of people in the system. Now they said find out LS, LQ, WS, WQ. Okay. So we will go direct into the formula. We have just written LS is a rho by 1 minus rho. This is what you have to remember. So you just put the values 8 by 9 divided by 1 minus 8 by 9. Okay. You will get 8 by 9 by 1 by 9. So 9 will be cancelled out. You will get 8. LQ is equal to LS minus lambda by mu, which is rho. So here he will get 8 minus 8 by 9. 64 minus 8. 64.9. Okay, it will be around 7.11. WS is equal to, from Little's equation, LS by lambda will give you, LS is 8 and lambda is also 8 per hour. So it will be 1 hour. WQ equal to LQ by lambda. So it will be 7.111 we have just found out, divided by 8. So it will become 0.888 hour, or you convert it into minute, it will be 53 minutes. Okay, so these are the steps which you need to follow in this chapter. So I'll send out these pictures, as well as in every book there are some formulas, and which we will discuss in the next class also. So please go through with the solved examples if possible. In next class we will also solve few more problems too. Okay, any questions?
No, sir.
Okay, then today's time is up, and we have lost a very good amount of time. But
Sir, attendance,
this
sir?
happens. Attendance. Acha, how to take attendance?
Sir,
Should
আপনি
I
ওখানে
call
একটা
with
স্ক্রিনশট নিতে পারেন স্যার।
just a minute? We have 49 people in the system. Screenshot. Okay, just the total number of people is not showing here. Just a second. Just stay connected. It's better I write out the roll numbers, because I think the roll numbers are available before your names.
Yes,
Okay,
sir.
let us take a screenshot. That will be very difficult. I'll write out faster. 87, 93, 97. If I miss out any roll number, please prompt. Okay. 87, 93, 97, 107, 108, 109, 110, 111, 113. Hold up. Let me finish. 3.
Sir, 95, sir.
95. Okay, I missed out 95. Hold up. 113 present, 115 present, 117, 118, 120, 121. Okay. 122, 124, 125, 130, 131, 132, 134, 138, 139, 140, 141, 142, 143, 144, 145, 146, 147, 150, 151, 152, 153, 154, 155, 156, 158, 159, 160, 161, 162, 163, 164, 166, 169, 95. Okay, so if you find a roll number here on my copy, then you can leave. Or
Yes, sir.
if anybody missing your roll number, please prompt me.